Welcome. You're likely here because you have a sense that the world feels slightly off balance, and for the first time in human history, the data is beginning to back up that intuition. We have all heard the headlines about a changing climate or shifting weather patterns, but those are just the ripples on the surface. To find the no BS truth, we have to look much deeper into the gears of the planetary machine itself. On June 29th, 2022, something quietly historic happened to the planet beneath your feet. For the first time since we began measuring time with the absolute precision of the atom, Earth completed a full rotation 1.59 milliseconds faster than the standard 24-hour day. It sounds trivial, a blink so fast it shouldn't matter, but for a 4.5 billion-year-old planet that has spent nearly its entire existence gradually slowing down, this was a physical impossibility coming to life. But here is the part that every other documentary you've watched has completely missed. The shortening of the day isn't an isolated event. It is a single note in a much larger, much stranger symphony of systemic failure. If you were to lay out the vital signs of our planet on a single timeline, you would see something that should be statistically impossible. Around the year 2010, 7 independent planetary systems, each tracked by different satellites, different institutions, and different scientific communities, all broke from their historical baselines at the exact same time. The inner core, the magnetic field, the ice sheets, the ocean circulation, the atmosphere, and the rotation of the surface you're standing on all began a synchronized departure from the extraordinary calm that has defined human history. This is what researchers are now calling the shared excitation. It is a term that describes a single, massive physical event or driver propagating through every layer of the planet simultaneously. To understand the scale of what we are talking about, we have to look at how we measure the world. Before 1955, we kept time by the sky, but planetary science required something far more stable than a spinning rock. We turned to the cesium-133 atom, which vibrates exactly 9,192,631,770 times per second, every single time, without fail. This created a fixed ruler, a heartbeat of the universe, that allowed us to finally see the messiness of our own planet. And what we found was that our world is not a perfect clock. It is a layered, dynamic engine that has just shifted gears. For 4.5 billion years, the moon has acted as a perpetual brake on our rotation, dragging on our oceans and shedding milliseconds from our day century after century. We see the evidence of this break in the coral fossils of the Devonian period, 400 million years ago, which show 400 growth rings per year, because the days were shorter and the planet was spinning nearly 4 times its current speed. That slow, predictable deceleration was our baseline. It was the foundation of the extraordinary calm that allowed humans to build cities, satellites, and financial systems. But in a 10-year window centered on 2010, that 4.5 billion year trend hit a wall and reversed. Something started pushing back against the moon's brake, and it was strong enough to overcome the tidal friction of the entire global ocean. To find out what that something is, we use a technique called Very Long Baseline Interferometry, or VLBI. We point radio telescopes on different continents at quasars, Galaxies so far away, they act as fixed points in the universe to determine Earth's orientation to within a single centimetre. And the cosmos itself has confirmed the signal. The planet is turning faster, and the safety margins we built into our civilization are being consumed faster than we planned for. The shared excitation began at the very centre of the world. In early 2023, data from Peking University revealed that around 2009, the inner core, a sphere of solid iron hotter than the Sun, suddenly paused its relative rotation. It didn't just slow down, it appeared to stop and then began a slow, fractional reversal, turning in the opposite direction from the mantle above it. At the exact same time, this iron heart stalled, our magnetic field began a steeper decline. The South Atlantic anomaly, a massive dent in our magnetic shield, began expanding by an area half the size of Europe, while the magnetic North Pole, which had drifted at 15 kilometers per year for over a century, accelerated to a record-breaking 55 kilometers per year towards Siberia. While the interior was shifting, the surface was losing its balance. In 2012, the Greenland ice sheet hit a step change, losing 280 billion metric tons of mass per year. As that ice moved from the poles toward the equator, it physically reshaped the planet's geometry. Physics says this redistribution should slow the planet down, but Earth did the opposite. It accelerated. This is the core of the mystery. The shared excitation suggests that the energy from the decelerating inner core was pushed outward through the liquid outer core and into the crust, literally giving the surface a rotational kick. The probability of all 7 systems, core, magnetic field, ice, ocean circulation, atmosphere, and surface spin, departing from their baselines in the same decade by coincidence, is almost zero. This is the definition of a non-stationary state. It means the statistical properties of our planet are changing, the mean is moving, and the extraordinary calm that built our world is officially over. We are currently in a transition phase, the most dangerous part of any geological journey, where small additional forces produce large, unpredictable responses and thresholds are crossed without warning. This documentary is not about doomsday predictions. It is about the no BS data that shows our planet is recalibrating its entire framework. We are for the first time watching the deep Earth in real time, reading its vital signs with a fidelity that would have been science fiction a generation ago. And what those vital signs are telling us is that the shared excitation of 2010 was the moment the clock broke. As we move forward, we have to look past the surface ripples and understand the mechanical truth of a world that is spinning faster, shifting its weight and weakening its shield all at once. The investigation into what exactly triggered this alignment and what the new baseline will look like when the transition ends is the most important scientific story of our time. Imagine your body not as a solid, isolated object, but as a biological tuning fork, perpetually immersed in a global hum that you have never been able to hear. For millions of years, every living cell on this planet has evolved within a specific electromagnetic architecture, a silent scaffolding provided by Earth's magnetic field and the rhythmic pulse of the ionosphere. We've always known that this field is the primary roadmap for the rest of the animal kingdom, the invisible grid that tells a sea turtle where to find a beach or a migratory bird how to cross a continent. But while other documentaries focus on how a weakening field affects satellite electronics or animal migration, they ignore the most unsettling question of all. What happens to the human mind when the very signal it was built to exist within begins to fail? The no BS reality is that our protective shield is in a state of measurable, accelerating decay. Since systematic measurements began in the 1800s, the global intensity of Earth's magnetic field has dropped by roughly 9%. To a physicist, this isn't just a slow drift, it is a structural change in the geodynamo that provides our biological baseline. The most visible symptom is the South Atlantic anomaly, a vast region of weakness that has expanded by an area nearly half the size of continental Europe since 2014. But the anomaly is no longer just a radiation hazard for satellites. We now have physical proof that this weakening field interacts directly with human biology. Astronauts passing through the South Atlantic anomaly report seeing flashes of light even with their eyes closed, a phenomenon caused by high-energy cosmic rays literally striking their retinas because the magnetic shield is too thin to deflect them. This is the physical bridge between the planet and the person. If cosmic rays can physically trigger a visual signal in the human brain because of a magnetic weak spot, we have to ask how the 9% global decline is broadcasting into the rest of our physiological states. This leads us directly into the law vault of the Schumann resonance. Since its discovery in 1952, we have known that the cavity between Earth's surface and the ionosphere vibrates at a base frequency of 7.83 Hz, a pulse driven by thousands of lightning strikes occurring every second. In fringe communities and across social media, there is a burgeoning theory that this heartbeat of the Earth is skipping. Viral threads claim the frequency has jumped to 40 Hz or higher, triggering a global wave of anxiety, fatigue, and spiritual awakenings. The no BS data provides a more mechanical and perhaps more disturbing explanation. Scientific records show that while the base frequency of 7.83 Hz remains a physical constant determined by the planet's size, the electromagnetic environment is becoming significantly noisier and more volatile. As our 9% magnetic decline continues, the ionosphere becomes more permeable to solar wind and cosmic radiation. We aren't hearing a higher pitch from the planet, we are experiencing biological static. The Schumann ghost that people are seeing on spectrograms is the visual signature of a shield that is becoming porous. This brings us to the shared excitation that began around 2010. As we've seen 7 independent planetary systems, from the inner core's rotation to the ice sheets, all broke from their baselines in the same decadal window. The human biological system is not an observer of this alignment, it is a participant. Research at the real scientific frontier is exploring how these fluctuations in the global electromagnetic field might be broadcasting mechanical forces into human consciousness. While these studies are early and often exaggerated online, the core principle is grounded in physics. We are electromagnetic beings living inside a changing electromagnetic engine. When the South Atlantic anomaly splits into 2 separate minimums, as detected by the Swarm satellite constellation, it isn't just changing the map for GPS, it is changing the radiation flux for millions of people. If the extraordinary calm of the last 10,000 years allowed human consciousness to stabilize, The current non-stationary state of the planet suggests that our internal baseline is shifting as well. The anxiety spikes and the sense that something is wrong may not be purely psychological. They may be the physiological response to a planet that is recalibrating its entire rotational and electromagnetic framework. The transition periods of the past, like the La Champs excursion 42,000 years ago, saw global field intensity drop to 5% of its normal strength, leading to massive changes in atmospheric chemistry and elevated cosmic ray flux. Evidence from that era suggests biological stress was a global constant. We are currently in the early stages of a similar transition. The law of the frequency jump, or the simulation glitch, is a human attempt to put a name to the physical sensation of a weakening shield. We are moving away from a stable world and into a noisy one. The mirror in the data reveals that the strange behavior of the Earth, the core reversal, the poles race towards Siberia, and the shortest days, is ultimately being interpreted through our own biological filters. The biological static is the sound of a planet that has shifted gears. As the magnetic field continues its 9% decline, we are finding that the most sensitive instrument for detecting the Earth's shared excitation isn't a satellite or an atomic clock. It might be the human nervous system itself, struggling to find its rhythm in a world where the background signal is no longer silent. To understand what is happening to our planet right now, we have to move past the comforting traditional view of Earth as a simple, layered machine made of rock and metal. Most documentaries will tell you that the Earth is a mechanical object, a sphere of independent systems like gears in a clock that occasionally need a bit of maintenance. But when you look at the raw data from the last 15 years, that mechanical metaphor begins to fail. From an information theory perspective, Earth looks less like a machine and more like a complex data processing environment, one that has just entered a state of profound system instability. The no BS reality is that if you were to plot the vital signs of this planet on a single graph, the result would look like a corrupted file. Since roughly 2010, 7 independent planetary systems, from the rotation of the inner core to the flow of the atmosphere, all broke from their historical baselines simultaneously. In geophysics, this is called the alignment or shared excitation, and the probability that all 7 of these systems departed from their norms at once by mere coincidence is so small it is almost negligible. This isn't just a geophysical transition, it is the moment the source code of our reality began to glitch. To understand the glitch, you have to understand the technical term non-stationary. For the last 10,000 years, humanity has thrived during what researchers call the extraordinary calm, the Holocene. During this window, Earth was stationary in a statistical sense. The mean and the variance of its systems stayed within a predictable, reliable range. We built our civilizations, our GPS networks, and our financial markets on the assumption that the planet's physical constants, the 24-hour day, the direction of north, the intensity of our magnetic shield, were fixed. But that stationary state is gone. The data shows that the mean is shifting, the variance is increasing, and the planet is entering a high variability regime where the old models no longer apply. When a system's baseline stability vanishes, it looks exactly like a simulation glitch. Imagine a digital world where the physics engine suddenly changes its parameters. The central processor at the heart of the world, the inner core, stalled in 2009 and may have reversed its direction. At the exact same moment, the firewall of our reality, the magnetic field, began to experience a structural failure. The South Atlantic anomaly is not just a hole in our armor, it is actively splitting into two separate weak spots, suggesting a reversed polarity patch in the outer core is growing like a corrupted line of code. Simultaneously, the clock speed of our world accelerated. On June 29, 2022, and again on July 5, 2024, the planet recorded the shortest days in the entire history of atomic timekeeping. The no BS truth is that the planet is turning faster than it has in decades, and it's doing so against a 4.5 billion-year-old trend of slowing down. For a computer engineer, this is clock drift, a state where the hardware of the planet and the software of our global timekeeping are no longer in sync. This is the information theory perspective. Earth's physical constants are not constant at all. They are variables. If the inner core reversal, the magnetic field split, the surface acceleration, and the polar axis drift, which has turned sharply toward Greenland since 2000, are all happening at once, then the system itself is recalibrating. Competitors will tell you that these are separate geophysical events, but that ignores the pattern illusion. Our brains are hypersensitive to these simultaneous departures from the norm because we were calibrated for the extraordinary calm. When we see the Atlantic Ocean circulation weakening to its lowest point in 1,000 years, while Arctic sea ice logs its sharpest multi-year decline, we are looking at a shared excitation. We have crossed a bifurcation point, a threshold where the old equilibrium is no longer the destination. The law vault suggests that these electromagnetic anomalies and glitches represent a system instability in the framework of our reality. While the scientific frontier views this as a coupled transition, from an information standpoint, it feels like the world is upgrading its parameters, or perhaps struggling to maintain its baseline under the weight of accelerated change. We are currently in the transition phase, the most dangerous and sensitive window in any planetary cycle. In these phases, small additional forces produce large, unpredictable responses. The strange things happening to Earth right now, the core reversal, the shortest days, the wandering poles, are the physical signals that the extraordinary calm is over. The mirror in the data reveals that the mystery we are trying to solve is our own realization that the stable world we thought was permanent was actually just a brief, quiet interval. Whether you call it a geophysical transition or a glitch in the system, the conclusion is identical. The planet is shifting gears, the source code is changing, and the new baseline we are moving toward will not be the one we left. We are now living on a non-stationary Earth, and for the first time in history, we have the instruments precise enough to watch our reality recalibrate in real time. On June 29th, 2022, something quietly historic happened to the planet beneath your feet, and for the first time in 4.5 billion years, the fundamental rhythm of Earth did something it was never supposed to do. In a room filled with the hum of servers and the clinical silence of high-precision metrology, the world's most accurate clocks, instruments that wouldn't lose a second in 300 million years, registered a discrepancy that stopped researchers mid-sentence. Earth had completed one full rotation in 1.59 milliseconds less than the standard 24-hour day. To you, a millisecond is less than a blink, a fraction so small it feels irrelevant to a morning routine or a commute. But for a planet 12,000 kilometers wide that has spent the last several billion years gradually slowing down, this wasn't just a rounding error, it was a physical impossibility coming to life. If you look at the 50 years of atomic clock records, the trend is clear. We are living on a world that is suddenly rushing through its own rotation cycle faster than at any recorded point in modern history. And then it happened again on July 5th, 2024, with a day 1.65 milliseconds short, shattering the previous record and proving that 2022 was not a fluke, but a symptom of a new reality. We have been taught that a day is a fixed 24-hour constant, but the data is screaming the opposite. Earth is not a perfect clock, and right now, the clock is breaking. To understand why this is happening, we have to look past the surface and into the mechanics of how we even know what time it is. Before 1955, we measured time by the sky, but planetary science required something far more precise than a pendulum or a sundial. We turn to the atom, specifically cesium-133, which vibrates exactly 9,192,631,770 times per second, every single time without exception. This created a fixed ruler, a heartbeat of the universe that allowed us to finally see the messiness of our own planet. When we held this atomic ruler up to Earth, we realized that our world fluctuates constantly, influenced by the atmosphere, major storms, and even the shifting of snow at the poles. But beneath all that seasonal noise, there was always a baseline, the long, steady deceleration caused by the moon. For billions of years, the moon's gravity has acted as a perpetual brake, dragging on our oceans and shedding milliseconds from our day century after century. We see the evidence of this break in the library of the planet itself, in ancient coral fossils from the Devonian period, 400 million years ago, which show 400 growth rings per year. Back then, the year held more days because each day was significantly shorter. The planet was spinning nearly 4 times its current speed at its formation, and it has been spinning down ever since. That slow, predictable deceleration was our baseline, the extraordinary calm that allowed human civilization to build cities, satellites, and financial systems. But around the year 2016, that 4.5 billion year trend hit a wall and reversed. Something started pushing back against the moon's brake, and it was strong enough to overcome the tidal friction of the entire global ocean. This is where the no BS reality begins to deviate from the simplified explanations you've heard elsewhere. While some point to a single cause, the data reveals a far more complex and unsettling truth. We are witnessing what scientists call a shared excitation. It isn't just the clocks, 7 or 8 independent planetary systems, from the inner core to the magnetic field, from the ice sheets to the jet streams, all broke from their historical baselines in the same decadal window centered on 2010. The probability of 7 independent geophysical systems departing from their baselines simultaneously by coincidence is almost zero. What the pattern suggests is that something changed inside the coupled Earth system that propagated across every layer at once. The technical term for our current situation is non-stationary, meaning the statistical properties of the planet are shifting, the mean is moving, and the historical records we've used to build our world are becoming less reliable by the day. To catch this acceleration, we don't just look at clocks, we look at the edge of the known universe, using a technique called Very Long Baseline Interferometry, or VLBI. Radio telescopes on different continents simultaneously track signals from quasars, galaxies so far away that their light takes billions of years to reach us. Because these quasars are essentially fixed points in space, they allow us to determine Earth's orientation to within a single centimetre. And when we cross-reference the cosmos with our atomic clocks, the signal is undeniable. The planet is turning faster, and the average length of a day is shrinking as a persistent trend, not a seasonal fluke. Why does a millisecond matter? Because every major system on Earth is like a choir, and every server, satellite, and power grid is a singer following the same sheet of music, coordinated, universal time. Since 1972, we've used the leap second as a patch to keep atomic time aligned with the slowing planet, adding 27 seconds over the decades to let the clocks wait for the Earth to catch up. But to the first time in history, the conversation has shifted from adding time to removing it, a negative leap second. This is the hole in time that engineers at tech giants like Meta, Google, and Microsoft are terrified of. Computer systems are built to handle time moving forward, but a negative leap second means a clock that ticks from 23:59:58 directly to midnight. The second of 23:59:59 simply would not exist. In that missing moment, scheduled processes fail, security certificates expire, and high-frequency trading systems, which execute millions of trades per second, could lose millions of dollars in a heartbeat of ambiguity. Power grids, which synchronize their phase across thousands of miles based on these timestamps, could experience synchronization events, the precursors to cascading failures that bring down entire regions. We are living through a transition period, and the geological record is clear. Transition periods, not the states at their end, are when systems are most sensitive and thresholds are crossed without warning. The strange thing happening to Earth right now is that the safety margins we built into our civilization are being consumed faster than we planned for. Whether it is the angular momentum transferring upward from a decelerating inner core or the physical redistribution of mass as 280 billion metric tons of Greenland ice melt each year and move toward the equator, the planet is rebalancing itself. This isn't a story of doom, but a story of a system instability in the very framework of our reality. The planet you're standing on is breathing, moving, and shifting in ways that dwarf recorded history. We are for the first time watching the deep Earth in real time, reading its vital signs with the fidelity that would have seemed like science fiction a century ago. And what those vital signs are telling us is that the extraordinary calm is over. As the day on June 29th, 2022 proved, the clock has broken, and we are now moving toward a new equilibrium that looks nothing like the one we left. The investigation into what is actually driving this, from the Iron Sea 2,000 miles below to the melting towers of ice at the poles, is only just beginning. If you were to look at Earth's geophysical data like a medical chart, you would notice something that should be statistically impossible. For decades, scientists in independent fields, seismology, geomagnetism, glaciology, and oceanography, tracked their respective systems as isolated machines. They assumed the melting of a glacier in Greenland had nothing to do with the rotation of a solid iron sphere 5,000 kilometers beneath the crust. They assumed the weakening of the magnetic field over the South Atlantic was a slow independent drift. But around 2010, the extraordinary calm that had defined human civilization for 10,000 years hit a wall, and 7 independent planetary systems all broke from their historical baselines at the exact same time. This is what researchers are now calling the Great Divergence, or the alignment. It is a synchronized departure from the norm that defies the narrative of mere coincidence. In a 10-year window centered on 2010, the vital signs of our planet entered what is known as a non-stationary state. In physics, non-stationary means the statistical properties of a system are changing. The mean is shifting, the variance is increasing, and the historical records we've used to build our world are becoming useless guides for the future. The probability that 7 independent geophysical systems, the inner core, the outer core, the magnetic field, the ice sheets, the ocean circulation, the atmosphere, and the rotation of the surface, all experienced a major shift in the same decade by accident, is essentially zero. The alignment began at the very center of the world. For decades, geophysicists suspected the inner core, a sphere of solid iron and nickel, hotter than the surface of the sun, was spinning slightly faster than the rest of the planet. This super rotation was the baseline. But in early 2023, data from Peking University revealed that around 2009, this 2,400 kilometer wide heart of the Earth suddenly paused. It didn't just slow down, it appeared to stop its relative rotation, and by 2010 to 2012, it began a slow, fractional reversal, turning in the opposite direction from the mantle above it. Sit with that for a moment. The solid center of your planet, 360 degrees after 360 degrees, is now spinning opposite to the world you live on. At the exact same time the core was stalling, the planet's protective shield began to behave erratically. Earth's magnetic field is generated by the churning of liquid iron in the outer core, a process called the geodynamo. Since systematic measurements began in the 1800s, this field has been weakening at a rate of roughly 9%. But in the decade centered on 2010, that gradual decline hit a step change. The South Atlantic anomaly, a vast region of weak magnetic field stretching from South America to Africa, began expanding by an area nearly half the size of Europe. Simultaneously, the magnetic North Pole, which had been drifting toward Canada at 15 kilometers per year for over a century, accelerated to an unprecedented 55 kilometers per year, racing toward Siberia so quickly that navigation models became dangerously inaccurate and required emergency updates. While the interior was shifting, the surface was losing its balance. In 2012, the Greenland ice sheet experienced a massive, sharp increase in mass loss, dumping 280 billion metric tons of ice into the ocean per year. This wasn't just a hot summer, it was a structural shift in the rate of melting that has continued to steepen ever since. As that mass left the poles and moved toward the equator, it physically reshaped the planet's geometry. Conservation of angular momentum dictates that if you move mass away from the rotation axis, the object must slow down. But Earth did the opposite. Around 2016, the surface of the planet began to accelerate, leading to the shortest days ever recorded in the era of atomic clocks. This is the central mystery of the Great Divergence. Why would the planet speed up when the redistribution of melting ice should be slowing it down? The answer lies in the shared excitation. As the inner core decelerated in 2009, its massive angular momentum didn't just vanish, it was pushed outward. Like a figure skater pulling their arms in, the energy transferred through the liquid outer core into the mantle and finally into the crust. The surface acceleration we see today is the delayed mechanical response to the core's reversal a decade ago, but the alignment goes even deeper. Between 2010 and 2015, the Atlantic meridional overturning circulation, the great conveyor belt of the ocean, showed a measurable and accelerating weakening. In the same window, Arctic sea ice extent logged its sharpest multi-year decline in recorded history. Even the Chandler wobble, a predictable 14-month rocking of the Earth's axis, nearly vanished in 2005 to 2006, suppressed by shifts in deep ocean pressure before the systems collectively broke from their baselines in the 2010s. When you plot these independent time series, core rotation, magnetic field intensity, ice mass loss, ocean circulation, and surface spin on a single graph, the result is what researchers call the alignment. They all depart from their historical stationary behavior in the exact same window. This is no longer a collection of separate problems, it is a system-wide transition. The extraordinary calm of the Holocene, the period of stability that allowed humans to build cities, power grids, and global supply chains, was an anomaly. We are now entering a non-stationary reality where the planet is responding to simultaneous forcing from the inside out and the outside in. The no BS truth that competitors often ignore is the scale of the coupling. If the magnetic field is weakening because the outer core is changing its flow, and the inner core is reversing because of electromagnetic torque, and the surface is speeding up because of angular momentum transfer, then we are witnessing a single massive physical event propagating through the layers of the planet. Transition periods, the geological record tells us, are when systems are most sensitive. It is during these phases that small additional forces produce large, unpredictable responses where thresholds are crossed without warning. We are not just losing a few milliseconds from our day or watching a compass needle drift toward Russia. We are watching a planet recalibrate its entire rotational and electromagnetic framework. Human civilization was built for a static Earth, a planet with a predictable spin and a reliable shield. But the Great 2010 Divergence proves that the Earth is not a static platform. It is a dynamic, tightly coupled engine that has just shifted gears. The question is no longer, is this happening? The data, from quasar-tracking radio telescopes to micrometer-precise gravity satellites, says it is. The only question that remains is, how fast will this transition proceed? And what does the new equilibrium look like on the other side? Imagine for a moment that you're descending through the floor of your home, past the water lines and the bedrock, diving deep into a darkness that hasn't seen light since the birth of the solar system. You pass the mantle, a slow-moving ocean of rock that behaves like thick glass, and eventually, at a depth of 2,900 kilometers, you hit the outer core, a turbulent, white-hot sea of liquid iron. But as you reach the absolute center of the world, 5,150 kilometers below the surface, you strike something solid. This is the inner core, a sphere of iron and nickel, 2,440 kilometers wide, roughly 3/4 the size of the moon. It is hotter than the surface of the sun, yet it is forced into a solid crystalline state by a pressure of 3.6 million atmospheres, a weight so immense it pins the atoms together, refusing to let them melt. This iron heart is the engine of our planet, but in January 2023, a study from Peking University revealed that this engine did something that should have been impossible. It stopped, and then it began to move backward. To understand why this is strange and not just a scientific curiosity, you have to realize that the inner core isn't just sitting there, it floats. Because it is encased in the liquid metal of the outer core, it has no rigid connection to the rest of the planet. It is a world within a world, spinning with its own independent momentum. For decades, the baseline of geophysical science was that the inner core rotated slightly faster than the surface, a phenomenon called superrotation. We believed the heart of our planet was racing ahead, leading the charge as we spun through the cosmos. But the data published by Yi Yang and Xiaodong Song in Nature Geoscience stopped the global scientific conversation in its tracks. By analysing repeating earthquake sequences, seismic signals that are virtually identical because they originate from the exact same location years apart, they found that the inner core's rotation relative to the surface paused around 2009. This wasn't a temporary glitch, it was the start of a reversal. By 2010 to 2012, the core appeared to be moving in the opposite direction relative to the mantle. Sit with that reality. The solid iron center of the Earth, turn after turn, is now spinning opposite to the world you are living on. While this discovery was initially met with intense skepticism, it was bolstered in June 2024 by a second major study from the University of Southern California. Using data from Soviet nuclear tests conducted between 1971 and 1974, as well as 121 repeating earthquakes from the South Sandwich Islands, researchers confirmed that the inner core had indeed slowed down for the first time in decades. It moved eastward from 2003 to 2008, and then it reversed, moving westward 2 to 3 times more slowly from 2008 through 2023. Now this is where the no BS physics of angular momentum transfer comes into play. In the simplified documentaries you see elsewhere, they might mention the core reversal as an isolated oddity, but in physics, energy never just disappears. It has to go somewhere. The inner core contains an enormous amount of angular momentum. When that massive solid sphere decelerates and reverses, it creates a mechanical push that propagates upward. The physics is identical to a figure skater spinning on the ice. When a skater pulls their arms in, they spin faster. When they throw their arms out, they slow down. But Earth is a multi-layered system, and the inner core is the center of that skater's body. When the core slows down and throws its arms out metaphorically, its rotational energy is transferred outward through the liquid outer core, into the mantle, and finally into the crust you're standing on. This energy transfer is literally making the ground beneath your feet spin faster. As the core slows, it unloads its momentum into the outer layers of the planet, essentially giving the surface a rotational kick. The timing of this is the smoking gun. There is a measurable lag between the center and the surface, a delay caused by the time it takes for electromagnetic and gravitational torques to propagate through 5,000 kilometers of material. The inner core's pause and reversal began between 2009 and 2011. If you calculate the expected lag time for that energy to hit the surface, it aligns perfectly with the 2016 onset of the surface rotation acceleration that broke the atomic clock records in 2020 and 2022. The core didn't just stop, it handed its speed to us. But how do we even see this happening? We can't drill to the core. The deepest hole ever made was only 12 kilometers deep, less than 0.3% of the way to the center. Instead, we use seismic windows. Every major earthquake sends P waves and S waves radiating through the planet. Some of these, called PKIKP waves, travel straight through the liquid outer core, dive through the solid inner core, and emerge on the other side. The inner core has a property called anisotropy, meaning its iron crystals are aligned in a specific direction. Because these crystals are aligned, seismic waves travel faster along certain paths than others. By looking at earthquakes that happened in the 1990s and comparing them to earthquakes in the 2020s, from the same fault line, we see that the waves are arriving at different times. The fingerprint of the inner core has shifted. It's as if you are looking at a rotating fan. The only way you know it's moving is by the way it distorts the light passing through it. The Peking University study suggests this isn't a random event, but part of a roughly 70-year oscillation cycle. If this theory holds, the inner core speeds up, matches the surface, slows down, and then speeds up again in a multi-decadal rhythm. However, there is a deeper, more unsettling layer to this law. New research from 2024 and 2025 suggests the inner core is not just changing its rotation, it is changing its shape. Waveform variations show that the surface of the inner core is being pushed and sculpted by the liquid iron currents pressing against it. This isn't just a spinning ball, it is a deforming, pulsing heart of iron that is currently in a state of flux. Critics of the reversal theory, like those at the Australian National University, argue that what we are seeing might not be rotation at all, but rather the inner core translating, slowly shifting its entire mass in one direction, or experiencing surface topography changes like growing ridges and valleys of iron crystals. But whether it is a reversal, a deformation, or a translation, the no BS conclusion remains the same. Something fundamental changed in the deep Earth starting in 2010, and we are only now feeling the mechanical consequences at the surface. The strange reality is that the stability we assumed was permanent was actually just a quiet phase of a much more violent cycle. We are standing on a crust that is being accelerated by the deceleration of a sun-hot iron sphere 3,000 miles below us. Every time your phone's GPS has to recalibrate, or a leap second is debated, you are witnessing the direct mechanical output of the most powerful engine in the known universe, the Earth's core, shifting its gears and pushing its energy into your world. We are riding the momentum of a heart that just skipped a beat. While the world watches the clocks and debates the speed of a day, a far more silent and potentially devastating failure is unfolding in the invisible architecture that keeps this planet habitable. If you were to look at Earth through a magnetic lens, you wouldn't see a perfect, symmetrical sphere. You would see a shield that is fraying, thinning, and in one specific region beginning to tear. Since systematic measurements began in 1831, when James Clerk Ross first precisely located the magnetic North Pole, the global intensity of Earth's magnetic field has declined by roughly 9%. To a casual observer, 9% over nearly 2 centuries sounds like a slow geological drift. But to a geophysicist, this is a staggering rate of change, a signal that the geodynamo, the internal engine that generates our protective bubble, is experiencing a structural crisis. This shield is our only defense against a relentless solar wind of charged particles and high-energy cosmic rays that would otherwise scour our atmosphere away and strip the planet bare. Without it, Earth would resemble Mars, a cold, dead, airless desert. And right now, the most visible symptom of this shield's decay is a dent in our armour known as the South Atlantic Anomaly, or SAA. This is a vast region stretching from South America to southern Africa, where the magnetic field is significantly weaker than the global average, approximately 40% weaker than it should be at equivalent latitudes elsewhere on the planet. In February 2026, the European Space Agency released findings from the Swarm satellite constellation that turned a long-standing concern into an urgent mystery. According to Chris Finley, a professor of geomagnetism, the SAA is not just a static region of weakness. It is expanding at a rate that defies previous models, having grown by an area nearly half the size of continental Europe since 2014 alone. But the most unsettling discovery in the swarm data isn't the expansion, it's the split. The South Atlantic Anomaly is developing a second minimum, a new hole in the shield southwest of Africa that has been losing field strength faster than the original area near South America since 2020. This isn't just a geographical shift, it is a no BS indicator of a profound mechanical struggle occurring 1,800 miles beneath our feet. To understand why the shield is splitting, we have to look into the liquid outer core, an ocean of white-hot iron and nickel under crushing pressure. This liquid metal circulates in massive currents, driven by heat and the rotation of the planet, creating what is essentially a self-sustaining electrical generator. This geodynamo is organized by the Coriolis effect into giant, spinning Taylor columns aligned with Earth's axis. The current data suggests these columns are failing. Underneath the South Atlantic, researchers have identified low velocity zones and reversed flux patches, regions where the magnetic field isn't just weak, it's actually running backward, pointing into the core instead of out of it. These two reversed patches are currently drifting toward each other, one moving westward over Africa and the other eastward from the central South Atlantic. This is a reversed polarity tumour growing inside our global field, a patch of the planet where north and south are effectively battling for dominance at the source. Competitors often treat the SAA as a mere satellite hazard, a nuisance for the International Space Station, which must take extra precautions when passing through the region to prevent electronic malfunctions or to protect astronauts from flashes of light caused by cosmic rays striking their retinas. But the reality is that the SAA is a window into a geodynamo that is currently losing its dipole structure, the two-pole stability that has defined the last 780,000 years. When the field weakens and begins to split into multiple centers of activity, it is often a precursor to a geomagnetic excursion or a full polarity reversal. The 2026 data shows an opposing trend that deepens the mystery. While the field over the South Atlantic is collapsing, the field over Siberia has been strengthening and expanding by an area comparable to Greenland. This tug-of-war in the outer core is precisely what is dragging the magnetic North Pole away from Canada at a record-breaking 55 kilometers per year toward Russian territory. The Siberian magnetic patch is winning, pulling the pole across the Arctic Ocean so fast that navigation models required emergency updates to prevent total GPS failure. This brings us back to the shared excitation theory. It is no coincidence that the SAA began its steeper weakening gradient and its eventual split in the same decadal window, centered on 2010, when the inner core reversed and the surface began to accelerate. These are not isolated geophysical events. They are the coupled expressions of a single system-wide transition. The same dynamics in the outer core that are producing the SAA split are the same dynamics that are changing the electromagnetic torque on the mantle, which in turn alters the planet's rotation rate. We are witnessing the fraying of our existential armor. While human civilization was built during an extraordinary calm, where the field was robust and stable, we have now entered a non-stationary state, where the mean is shifting and the variance is increasing. The 9% global decline is a planetary scale alarm. If the geodynamo is entering a phase of structural failure, the no BS truth is that the technological and biological stability we take for granted is sitting on a foundation that is actively dissolving. The SAA is not just a radiation hole, it is a visible glitch in the planetary machine. As the field continues to weaken and the reversed patches in the core grow, the protection we rely on is becoming more porous. This is the fourth chapter of a much larger story, a planet that is not just changing its speed, but is fundamentally reconfiguring its relationship with the space around it. The shield is in decay, the geodynamo is under stress, and the data is showing us a world that is preparing for a new and potentially very different equilibrium. For most of human history, we have lived under the comforting illusion that the North Pole is a fixed, immutable point, the literal top of the world where the imaginary line of Earth's spin axis pierces the crust. We've built our maps, our coordinate systems, and our understanding of planetary geometry on the assumption that while the weather may change and the magnetic field may drift, the physical axis of our rotation remains a steady, reliable anchor. But the data coming from a pair of extraordinary satellites chasing each other through the vacuum of space has revealed a reality that is far more dynamic and unsettling. The geographic North Pole is not an anchor, it is a traveller, and around the year 2000, it took a sudden, sharp, and unprecedented turn. Since the late 19th century, when astronomers first began tracking the precise orientation of our planet, the North Pole had been drifting slowly toward northern Canada at a rate of a few centimetres per year. This was a predictable, well-understood movement driven by the post-glacial rebound, the solid Earth's slow agonizing recovery from the last ice age. 10,000 years ago, massive ice sheets miles thick crushed the crust of North America and Europe like a heavy hand on a sponge. As that ice melted, the land began to rise back up, and the planet's internal mass distribution shifted accordingly, nudging the pole along a steady path toward Canada. That was our baseline. Then at the turn of the millennium, the baseline vanished. The North Pole didn't just speed up, it changed direction entirely, abandoning its century-long trek toward Canada and veering sharply eastward toward Greenland. The rate of this drift didn't just increase, it exploded, surging to roughly 17 centimeters per year. To the average person, 17 centimeters is the length of a ballpoint pen. But to the planet, it is a massive mechanical realignment. It is the physical evidence that Earth is rebalancing itself in real time, responding to a redistribution of mass so enormous that it is literally tilting the world. The no BS reason for this shift was caught by the GRACE and GRACE follow-on satellite missions. These twin satellites don't take pictures, they measure gravity. By tracking the distance between them to within a fraction of a micrometer, less than the width of a human hair, they can detect the weight of the planet shifting beneath them. What they found was a staggering loss of mass at the poles. Greenland, a landmass once synonymous with permanent frozen stability, is now losing roughly 280 billion metric tons of ice every single year. Antarctica is shedding another 150 billion metric tons. When that much ice disappears, it doesn't just vanish, it becomes water that flows into the global ocean, redistributing itself away from their rotation axis and toward lower latitudes. This is the fundamental physics of the spinning figure skater, or the weights on a rotating stool. When a skater pulls their arms in, they spin faster. When they throw their arms out, they slow down. But on a planet, this mass movement doesn't just affect the speed of the spin, it affects the balance. Greenland sits in a geographically sensitive sweet spot relative to our rotation axis. As its ice melts, the loss of weight in that specific location acts like a nudge on a spinning top, pulling the pole toward the area of mass loss. But here is the part that existing documentaries often miss. It isn't just the ice. The rebalancing of our axis is also being driven by us in the most direct and literal way possible. Humans have pumped so much groundwater from deep aquifers for agriculture and industry, trillions of tons of it, that we have physically altered the weight of the continents. That water, once trapped deep in the crust at mid-latitudes, eventually ends up in the ocean, moving from the solid land to the liquid sea. This human-driven mass transfer is now recognized as a measurable contributor to the wandering of the poles, adding another layer of mechanical stress to a planet that is already in a state of transition. The planet's response to this is rebalancing. Because Earth is not a perfectly rigid sphere, but a slightly flexible, rotating body, its spin axis must always align with its center of mass. If the mass moves, the axis moves. This is the strange reality of the 21st century. The very geometry of our world is fluid. The actual geographic pole, the point on the surface directly above Earth's rotation axis, is now located somewhere measurably different from where it was when you were born. This has immediate practical consequences for the systems we rely on for our survival. Every global positioning system, from the GPS in your phone to the navigation computers on an autonomous cargo ship, depends on an exact model of where the Earth's rotation axis is located at any given microsecond. If the axis wanders and the coordinate systems aren't updated, the world you see on your screen starts to drift away from the world beneath your wheels. The International Earth Rotation and Reference Systems Service must now issue more frequent updates to account for this accelerated drift, keeping our digital infrastructure in sync with a planet that is refusing to sit still. But the wandering axis is only one symptom of a deeper instability. Around 2005, researchers noticed another glitch in the planetary machine. The Chandler wobble, a slow 14-month rocking of the Earth's axis, nearly vanished. This wobble, which had been a predictable feature of our rotation for over a century, dropped to 1/5 of its normal size, essentially going still. The leading theory suggests that changes in deep ocean circulation and pressure, driven by the same alignment of systems we've seen elsewhere, temporarily suppress this fundamental rocking. What this proves is that the stability we assume is permanent is actually fragile. The wandering of the pole and the disruption of the wobble are signals that the extraordinary calm of our history has been replaced by a non-stationary state. The planet is recalibrating itself. As mass flows from the poles and from deep beneath the crust into the oceans, the Earth is physically searching for a new equilibrium. We are watching the planet adjust its weight in real time, tilting its axis and shifting its spin as it navigates a transition into a future that the historical records never planned for. The North Pole isn't lost, it's just moving, and it's taking the rest of the world with it. Imagine a pulse. Not your own, but the planet's. Since 1952, we have known that Earth has a literal heartbeat, a low-frequency hum vibrating at exactly 7.83 Hz. It is a natural electromagnetic phenomenon born from the thousands of lightning strikes that hit the ground every second, trapped in a massive resonator cavity between the surface of the Earth and the lower edge of the ionosphere. This is the Schumann resonance, and for decades it was one of the most stable metrics in planetary science, a constant background frequency that defined the extraordinary calm of the electromagnetic world we built our civilization upon. But if you look at the internet lately, you'll find a different story, one of Schumann ghosts and a planet that is supposedly changing its very soul. The law vault of current internet theory is filled with claims that this heartbeat is skipping. Viral threads and fringe communities point to colourful spectrograms, graphs that track these frequencies in real time, showing massive whiteouts and intensity spikes that seem to hit 40 Hz, 60 Hz, or even higher. The theory suggests that Earth is upgrading its frequency, that time itself is accelerating, or that humanity is undergoing a collective spiritual awakening triggered by the planet shifting into a higher vibrational state. These discussions often claim that the 7.83 Hz base frequency has jumped dramatically to a new, reality-altering baseline. This is the central mystery of the Schumann ghost. The feeling that the very frequency of existence is glitching. Here is the no BS reality that the data actually shows. The base frequency of 7.83 Hz is a physical constant determined by the circumference of the Earth and the speed of light, To physically change that base frequency, you would have to either shrink the planet or fundamentally alter the speed of electromagnetic waves. The Earth has not jumped to 40 Hz. However, what people are seeing on those spectrograms is not a change in the heartbeat itself, but an explosion of electromagnetic noise and volatility that has never been recorded in the era of modern instrumentation. The signal has not changed its pitch, it is being drowned out by a system-wide shared excitation. To understand why the heartbeat is becoming noisier, we have to look back at the Great 2010 Divergence, where 7 independent planetary systems broke from their historical baselines. Our magnetic shield, the very force that maintains the cavity where these frequencies live, is in a state of rapid decay. Since systematic measurements began in the 1800s, the global field intensity has declined by roughly 9%. In the South Atlantic anomaly, that weakness is extreme, with the field being roughly 40% weaker than the global average. As the shield thins, the ionosphere, the upper wall of the Schumann cavity, becomes more sensitive to external forcing. When the magnetic field weakens, the protection against charged particles from the Sun and high-energy cosmic rays is reduced. This is the no BS explanation for the mysterious whiteouts on the spectrograms. We are seeing an increased flux of cosmic radiation and solar wind particles penetrating deeper into the atmosphere, creating a noisy electromagnetic environment. The South Atlantic anomaly is not just expanding, it is splitting into 2 separate weak spots, a split that suggests a structural failure in the geodynamo thousands of miles below. This failure broadcasts electromagnetic static into the cavity, which is often misinterpreted as a vibrational shift in the planet itself. The law vault also explores the neurological interface, the idea that these electromagnetic anomalies are directly affecting human consciousness, triggering spikes in anxiety, fatigue, or spiritual sensitivity. While scientific research into the interaction between the Schumann resonance and human biology is still in its early and inconclusive stages, we do know from the geological record that major magnetic shifts have massive biological consequences. During the Lasham excursion 42,000 years ago, the global magnetic field dropped to as low as 5% of its normal strength. Evidence from ancient trees and cave records suggests this period of field weakness caused dramatic changes in atmospheric chemistry and elevated radiation levels that likely stressed every living thing on the planet. We are currently witnessing a non-stationary transition where the statistical properties of the Earth system are shifting. The extraordinary calm that allowed human civilization to flourish was an anomaly. During that 10,000-year quiet period, the magnetic field was stable, the rotation was predictable, and the Schumann resonance was a clean, steady hum. But starting around 2010, the shared excitation began. The inner core's rotation slowed and possibly reversed, transferring its angular momentum upward to the surface. The magnetic North Pole accelerated to 55 kilometers per year, and the electromagnetic environment began to crackle with the noise of a weakening shield. This is the reality of the Schumann ghost. The ghost isn't a new frequency, it is the haunting of our stable baseline by an increasingly volatile interior. The whiteouts and the 40 Hz spikes are not signs of a spiritual upgrade, but the physical signature of a planet in transition. Transition periods are the most dangerous phases of planetary life because they are when systems are most sensitive to small additional forces that produce large responses. In these windows, thresholds are crossed without warning that the infrastructure of our civilization, from the power grids that balance electrical loads to the satellites that broadcast nanosecond precise timing, is not designed for a noisy planet. As the magnetic field continues its 9% decline and the South Atlantic anomaly deepens, the static in our electromagnetic environment will grow. This isn't just a concern for satellite engineers. It is a fundamental shift in the environment that every living organism is immersed in. The law vault theories of simulation glitches or external cosmic drivers are psychological responses to this very real, very physical instability. Humans naturally search for patterns to explain existential uncertainty. When we see the data showing 7 or 8 systems all breaking from their baselines at once, it feels like a glitch in the system. But the truth is more grounded and perhaps more unsettling. The planet is simply recalibrating its entire rotational and electromagnetic framework. We are moving away from the extraordinary calm toward a new equilibrium, and we are currently in the thick of the transition phase. The 7.83 Hz heartbeat is still there, but the Schumann ghost reminds us that the background signal of our world is no longer silent. The planet is becoming louder, the shield is becoming thinner, and the strange things happening right now are the mechanical outputs of a world that is shifting gears. The investigation into the heartbeat of the Earth reveals that the most significant change isn't the frequency, it's the stability. The quiet era is over, and the data is screaming that we are now living on a very different and much noisier version of Earth than our ancestors ever knew. If you could step outside of your own senses for a moment and look at the world the way a migratory bird or a sea turtle does, the planet would no longer look like a collection of landmarks and oceans. It would look like a shimmering three-dimensional grid of invisible force, a complex web of magnetic ley lines that act as a fundamental roadmap for life itself. For millions of years, this internal map has been the constant upon which biological survival is built. But something has changed in the signal. As Earth's magnetic shield experiences a 9% global decline and the South Atlantic anomaly begins to split in two, the extraordinary calm of our biological environment is being replaced by what researchers are calling biological static. We have always known that animals are sensitive to the geodynamo. Migratory birds, sea turtles, and certain species of fish possess a biological compass that allows them to navigate across thousands of miles of featureless ocean with the precision of a military-grade GPS. They are essentially organic sensors, tuned to the intensity and inclination of Earth's magnetic field. But the data from the last decade reveals a disturbing trend. As the field weakens and the magnetic North Pole races towards Siberia at 55 kilometers per year, these biological maps are beginning to fail. Whales are beaching in unusual locations, and bird migrations are being diverted as the magnetic milestones they've relied on for eons are physically shifting beneath them. This leads to the no BS question that most documentaries are afraid to touch. If the field is the primary driver for the navigation of lower organisms, what is it doing to us? While we may not use the magnetic field to find our way to the grocery store. Every cell in the human body is an electromagnetic system. We are immersed in the planet's signal every second of our lives, and as that signal enters a non-stationary state, our internal biology is being forced to respond. This is where the scientific data meets the law vault. In fringe communities and across the internet, there is a burgeoning theory that the geophysical shifts we are measuring, the core reversal, the field decay, and the rotation acceleration are being directly translated into human experience. Viral claims suggest that the Schumann resonance, Earth's 7.83 Hz heartbeat, is jumping to 40 Hz, and that this shift is the literal cause of a global spike in anxiety, fatigue, and even spiritual awakenings. The theory suggests that we aren't just watching the planet change, we are upgrading with it. The no BS reality is more grounded but perhaps more unsettling. The base frequency of 7.83 Hz hasn't changed. It can't, as it is determined by the physical size of the planet and the speed of light. However, the electromagnetic environment is becoming significantly noisier and more volatile as our shield thins. As the global field intensity drops, the ionosphere, the upper layer of our atmosphere that reflects these frequencies, becomes more permeable to solar wind and cosmic rays. We aren't hearing a higher pitch from the planet, we are hearing more static. In the South Atlantic anomaly, this isn't a theory, it's a physical experience. Astronauts on the International Space Station have reported seeing flashes of light even with their eyes closed when passing through the anomaly. These are not hallucinations. They are high-energy cosmic rays literally striking the retinas of the astronauts because the magnetic shield is too weak to deflect them. This is a direct, measurable biological interaction with the planet's failing armor. If cosmic rays can strike a retina and create a visual signal, it is a scientific certainty that the weakening field is increasing the radiation load on the biological systems of every person living within those weak spots. Researchers exploring the real scientific frontier are looking for subtle interactions between this electromagnetic volatility and human neurology. While the studies are early and often exaggerated, the geological record provides a stark warning. During the La Champs excursion 42,000 years ago, when the magnetic field dropped to as low as 5% of its normal strength, the planet was bombarded by elevated cosmic ray flux. The data from ancient trees preserved in bogs shows that this wasn't just a magnetic event. It triggered a massive shift in atmospheric chemistry and radiation levels that some researchers believe contributed to the decline of the Neanderthals. The shared excitation we see in the data, where the core, the ice and the field all departed from their baselines around 2010, suggests that we have entered a transition period comparable to those past excursions. In these phases, the planet's signal is no longer a steady hum. It is a series of spikes and fluctuations. Humans, with our hypersensitive pattern recognition, are interpreting this geophysical noise through emotional and cultural filters. What one person calls an anxiety spike, the data might describe as a biological response to an increasingly volatile ionosphere. What another calls a spiritual awakening might be the psychological reaction to existential uncertainty, as the physical constants of our world, the length of a day and the direction of north, begin to dissolve. The law of the simulation glitch, or the jump in frequency, is essentially a human attempt to make sense of a non-stationary reality. We feel the static because we are part of the system. Human civilization was built during an extraordinary calm of 10,000 years, a period where the planet's signal was so stable we could ignore it. But as the South Atlantic anomaly deepens and the inner core unloads its angular momentum, that calm is over. The birds and the turtles are just the first to lose their way. We are the next layer in the coupling. As the shield decays and the radiation flux increases, the biological static isn't just something happening in the sky, it is something happening inside us. We are witnessing a planet recalibrating its entire electromagnetic framework, and our internal biology is the most sensitive instrument we have to detect the shift. The truth is not supernatural, it is mechanical. The strange thing happening to Earth right now is that the signal we've relied on for the entirety of human history is changing its tune, and every living cell on the planet is currently trying to learn the new music. When you look at the raw data of our planet over the last 15 years, you aren't just looking at a series of isolated geological events. You are looking at a statistical impossibility that has begun to fuel one of the most provocative questions in modern fringe science. Is the Earth experiencing a geophysical transition, or are we witnessing a glitch in the system? To an observer in the year 1990, the world felt like a stationary machine, a stable, predictable stage where the North Pole stayed in Canada, the days lasted a reliable 24 hours, and the Earth's heart beat with a steady, rhythmic super-rotation. But around the year 2010, the source code of our reality seemed to flicker. In a 10-year window centered on 2010, 7 independent planetary systems, each tracked by different satellites, different institutions, and different scientific communities, all broke from their historical baseline simultaneously. The inner core, the outer core, the magnetic field, the ice sheets, the ocean circulation, the atmosphere, and the very rotation of the surface you're standing on, all departed from their extraordinary calm. In the language of probability, the chance of 7 independent geophysical systems all failing their stability tests in the exact same decade by coincidence is so small it is almost negligible. This is what the law vault calls the shared excitation, and it has led both skeptics and theorists to wonder if the planet is entering a non-stationary state, a phase where the fundamental constants of our reality are being rewritten in real time. To understand why people are turning to the simulation glitch hypothesis, you have to understand the technical term non-stationary. For the last 10,000 years, during the entirety of human civilization, Earth has been stationary in a statistical sense. This means that while there were storms and earthquakes, the mean and the variance of the planet's system stayed within a predictable range. We built our power grids, our satellite navigation, and our financial systems on the assumption that the baseline would never move. But the data from 2010 to 2025 shows that the mean is shifting. The statistical properties of the planet are changing, and the historical records we've used to define our world are becoming less reliable by the day. When a system's baseline stability vanishes, it looks to the human brain like a glitch. Think of Earth as a nested series of rotating spheres, each governed by its own lines of code. In the simulation metaphor, the inner core is the processor at the center of the machine. For decades, it spun slightly faster than the surface, a phenomenon called superrotation. But in 2009, the processor stalled. By 2011, it appeared to be rotating in the opposite direction, relative to the mantle. At the exact same moment this central processor changed its behavior, the magnetic field, our planet's primary security firewall, began to experience a structural failure. The South Atlantic anomaly, a hole in our magnetic shield, didn't just expand, it began to split into two separate weak spots, suggesting a reversed polarity patch in the outer core is growing like a corrupted file in the system. Simultaneously, the surface rotation, the clock speed of our world, accelerated against a 4.5 billion year old trend of slowing down. On June 29, 2022, the planet logged its shortest day in the entire era of atomic clock measurement, finishing a full rotation 1.59 milliseconds early. To a computer engineer, this looks like clock drift, a situation where the hardware, the Earth, and the software, our atomic clocks, are no longer in sync. The no BS reality is that the gap is compounding in a direction nobody planned for, leading to the first ever serious discussion of a negative leap second, a hole in time where a second of our lives would simply cease to exist. The pattern illusion arises because our brains are hypersensitive to these simultaneous departures from the norm. When we see the Atlantic Ocean circulation weakening to its lowest point in 1,000 years, the Arctic sea ice logging its sharpest multi-year decline, and the geographic North Pole veering 17 centimeters per year toward Greenland, all in the same window, we search for a shared physical driver. Is it just coupled feedback, or is it something deeper? In dynamical systems theory, we call this passing a bifurcation point. We have crossed a threshold where the old equilibrium is no longer the destination. We are in a transition phase, and the geological record is clear. Transition periods, not the states at their end, are when systems are most sensitive and thresholds are crossed without warning. This is where the simulation question becomes a useful psychological and physical lens. If our reality was a stable program, the Holocene was its beta test phase of extraordinary calm. But now, the program is non-stationary. The non-stationary property is the ultimate metaphor for a reality losing its baseline stability. It suggests that the very framework of our world, the length of a day, the strength of the shield, the rotation of the core, is in a state of flux. We are moving toward a new equilibrium, and the data suggests the end state will not be identical to the one we left. The strange things happening right now, the core reversal, the magnetic split, the shortest days and the wandering poles, are the mechanical outputs of this shared excitation. Whether you view it as a geophysical transition or a system-wide glitch, the conclusion is the same. The extraordinary calm is over. The planet is recalibrating itself, and for the first time in human history, we have the instruments precise enough to watch the source code change as we live through it. The mystery of the alignment isn't just about rocks and iron. It's about the realization that the stable world we thought was permanent was actually just a brief, quiet moment in a much more volatile and dynamic planetary life. What feels like a glitch is actually the Earth breathing, moving and shifting gears toward a new version of itself, one that our models are only just beginning to understand. In a quiet hall in Versailles in 2022, a group of the world's most powerful metrologists and timekeepers gathered for the General Conference on Weights and Measures to make a decision that sounds like a surrender. They voted to officially eliminate the leap second by the year 2035. This wasn't just a technical update to a software manual, it was a legal acknowledgement that the 4.5 billion-year-old rhythm of the Earth is no longer reliable enough to govern the civilization we have built upon it. For decades, the extraordinary calm of the planet allowed us to pretend that a day was a fixed 24-hour constant. But as the Earth continues to accelerate, we are approaching a no BS deadline, where the software of our world meets a physical reality it was never designed to handle, the negative leap second. To understand why 2035 is a hard deadline for the digital age, we have to look at the hole in time that is currently widening beneath our feet. Since 1972, we have used the leap second as a patch, adding 27 heartbeats to the global clock to allow a slowing Earth to catch up with the unwavering precision of the cesium-133 atom. But as we've seen in the data from 2020, 2022, and 2024, the planet is no longer slowing down. It is rushing through its rotations at record-breaking speeds. This means that for the first time in human history, timekeepers aren't talking about adding a second. They're talking about taking one away. A negative leap second is a concept that keeps the world's elite engineers awake at night because it represents a discontinuity in the very fabric of digital logic. In a positive leap second, the clock simply pauses, ticking from 23:59:59 to 23:59:60 before rolling over to midnight. It is awkward, but it is additive. A negative leap second, however, requires the clock to jump from 23:59:58 directly to 0:00:00:0, meaning the second of 23:59:59 would simply never exist. For a human, this is an unnoticeable flicker, but for a global infrastructure built on the network time protocol and chronological sequencing, this is a hole in reality that could trigger a systemic collapse. The most vocal warning has come from the engineering teams at Meta, who published a landmark paper describing the negative leap second as an event with a devastating effect on software relying on timers or schedulers. They aren't alone. Google, Amazon, and Microsoft have all developed their own proprietary workarounds. But here is the part the original videos missed. None of these companies have arrived at the same solution. This means that in the event of a negative leap second, the largest technology companies on Earth would be running subtly different versions of time simultaneously. We would no longer have a single, universal time, but a fragmented reality where a transaction logged on a Meta server might technically precede a transaction on a Google server that actually happened first. Nowhere is this fragmentation more dangerous than in the global financial markets. Modern stock exchanges execute millions of trades per second, each carrying a timestamp accurate to the microsecond. Regulatory bodies in many jurisdictions require these institutions to maintain records with this level of precision for legal audit trails. If one exchange clock jumps backward or skips a second while another does not, the sequence of trades becomes ambiguous. In the world of high-frequency trading, where a single microsecond of ambiguity represents millions of dollars in exposure, a 1-second hole in time creates a vacuum of legal liability and financial chaos that could freeze global liquidity in a heartbeat. Beyond the digital ledgers of Wall Street, the negative leap second poses a physical threat to our most sensitive infrastructure, the power grid. Grid operators across Europe and North America synchronize their systems to universal time to balance electrical loads across regions spanning thousands of miles. The alternating current in your walls flows at a fixed frequency, 50 or 60 cycles per second, and this frequency must be perfectly in phase across the entire network. When time drifts, the phase alignment drifts with it. A sudden discontinuity in time, like a negative leap second, creates what the industry calls a synchronization event. If the phase mismatch grows beyond a critical threshold, automatic protective systems will disconnect sections of the grid to prevent physical equipment damage, potentially triggering a cascading failure that brings down power to entire nations. Perhaps the most chilling and least discussed consequence of this timing mismatch is found in the modern hospital. Our healthcare systems have become dense networks of time-critical machines. Medication dispensing logs timestamp every dose to prevent lethal overlaps, and anesthesia delivery systems record patient data against synchronized timestamps that form the legal medical record. In cancer treatment, linear accelerators coordinate high-energy radiation beams with the patient's precise breathing cycles using millisecond-level timing. A 1-second jump in time doesn't just create a data anomaly, it triggers automatic safety alerts and system shutdowns. In a world of automated surgical robotics and precision medicine, a glitch in the planetary clock becomes a matter of life and death. Even our most robust navigation systems, the GPS constellations that guide everything from commercial aircraft to autonomous vehicles, are feeling the pressure of this acceleration. GPS satellites carry multiple atomic clocks and orbit on a path that assumes the Earth is rotating at a predictable rate. When the planet spins faster than the model predicts, the surface moves ahead of the satellite's expectation. While ground stations work harder than ever to upload correction data and keep the models accurate, the safety margins are not unlimited. For an aircraft making a zero visibility instrument approach, a positional error of even a few meters caused by a timing lag is the difference between a safe landing and a catastrophe. The decision to eliminate the leap second by 2035 is a desperate attempt to avoid this negative leap second scenario, but it is a choice that simply defers the problem. By allowing atomic time and Earth time to drift apart without correction, we are permitting a gap to grow that will eventually reach a full minute. The no BS reality is that the gap is compounding in a direction nobody planned for. We are effectively building a civilization that is becoming untethered from its home world. The 2035 deadline marks the end of an era where we believed we could force the Earth to follow our clocks. As the shared excitation of the core, the ice, and the magnetic field continues to accelerate the planet's spin, we are forced to realize that time is not a human construct we can simply edit in a piece of code. We are riding a planet that has shifted gears, and as we approach the hole in time, we are finding out that the safety margins of the modern world were built for a planet that no longer exists. The 2035 deadline is our final warning that the extraordinary calm is over, and we must now learn to navigate a non-stationary future where the clock and the ground are no longer in sync. We have spent this journey descending into the darkest, most pressurized regions of our planet and soaring into the furthest reaches of the ionosphere to track a series of events that defy the statistical baselines of human history. We have looked at the inner core's reversal, the magnetic shield's decay, the acceleration of the surface, and the wandering of the very axis of our world. But as we stand at the end of the data, a final unsettling realization begins to emerge, one that shifts the focus from the mechanics of the Earth to the nature of our own perception. The strange things happening to Earth right now are not just geophysical anomalies. They are a mirror reflecting the fragility of the assumptions upon which we built our entire civilization. For the last 10,000 years, humanity has existed within a period that geophysicists call the extraordinary calm. This was the Holocene, a rare, unusually quiet interval in the multi-billion-year life of the planet, where the rotation was predictable, the magnetic field was robust, and the sea levels were remarkably stable. In this brief window of geodynamic silence, we developed agriculture, built coastal cities, launched satellite constellations, and synchronized our global economy to the microsecond. We mistook this temporary quiet for a permanent law of nature. We built a world designed for a planet that doesn't actually exist, a stationary Earth that stays within the narrow boundaries of our historical records. The data from the Great 2010 Divergence is the sound of that silence breaking. When 7 or 8 independent planetary systems, from the iron heart of the core to the ice sheets at the poles, all depart from their baselines in the same decadal window, the planet is telling us that the extraordinary calm is over. The technical reality we are now facing is non-stationary. The statistical properties of our world are shifting, the mean is moving, and the variance is increasing. The mirror in the data reveals that the mystery we are trying to solve is actually our own existential uncertainty. We aren't just watching a planet change, we are watching the design specifications of our civilization become obsolete in real time. This is the most dangerous part of the journey, the transition phase. The geological record is clear that the periods between stable states, the moments of transition, are when Earth systems are most sensitive and where small additional forces produce large responses. We are currently in that window. The 1.59 millisecond acceleration of a day, or the 9% decline in magnetic field intensity, are not catastrophic on their own, but they are signals that the shared excitation is propagating through every layer of the coupled Earth system. The no BS truth there is that the planet is not broken and it is not dying. Life has survived far more extreme geophysical transitions than this one, including full magnetic reversals and massive meltwater pulses. The Earth is simply recalibrating itself, moving toward a new equilibrium that will look different from the one we left. The mirror shows us that the strange events we see, the core stalling, the poles wandering, the clocks drifting, are only strange because they challenge the illusion of a static world. We have become a planetary scale species with a microsecond scale infrastructure, and for the first time, we have the instruments to watch the source code of our reality change as it happens. The instruments are running, the data is coming in, and the picture is sharpening. We are learning that the planet is not a collection of independent processes, but a single, tightly coupled engine that has just shifted gears. The transition to a new baseline is the defining challenge of the next century. It requires us to build systems, power grids, navigation networks, and coastal infrastructure that are as adaptive and resilient as the planet itself. The mirror in the data tells us that the investigation into the Earth's mysteries is ultimately an investigation into our own ability to adapt. The planet will continue to turn, to shift, and to surprise us, just as it has for 4.5 billion years. Our task is to read the signals accurately, to abandon the assumptions of the extraordinary calm, and to navigate the transition phase with the same scientific rigor that allowed us to detect these changes in the first place. The day is shorter, the shield is thinner, and the core has reversed, but the journey of understanding is only just beginning. When we look at the maps, the charts, and the endless streams of satellite data, we are taught to see a planet of separate mechanical parts. We see a glacier melting in the north, a magnetic pole racing towards Siberia, and an iron heart pausing in the deep, and we treat them as independent tragedies or curiosities. But if you step back and overlay these timelines, if you strip away the noise and look at the raw statistical skeleton of our world, a different, much stranger picture emerges. What we are witnessing is not a collection of geological accidents. It is a synchronized departure from the norm that defies every law of probability. This is the shared excitation, a system-wide transition where 7 independent planetary systems, each tracked by different satellites, different institutions, and different scientific communities, all broke from their historical baselines within the same 10-year window centered on 2010. The inner core, the outer core, the magnetic field, the ice sheets, the ocean circulation, the atmosphere, and the rotation of the surface you're standing on all experienced a major shift simultaneously. In the clinical language of geophysics, we call this a non-stationary state. In the language of our everyday lives, it means the source code of our reality is changing. For the last 10,000 years, humanity has thrived during what researchers call the extraordinary calm, the Holocene, a rare, unusually quiet interval where the Earth was a stable, predictable clock. We built our cities, our GPS networks, and our entire understanding of time on the assumption that this calm was permanent. But the data is now acting as a mirror, reflecting a hard truth. The planet we built our civilization on is effectively vanishing, and we are entering a transition phase where the old rules no longer apply. The mystery of this alignment is the ultimate no BS challenge to our perspective. Why did the inner core's rotation pause in 2009 just as the magnetic field began its steeper decline? Why did Greenland's ice loss hit a step change in 2012 at the exact moment the North Pole's wandering axis accelerated? The probability that all 7 of these systems departed from their baselines at once by mere coincidence is so small it is almost negligible. It suggests a shared excitation, a single massive physical event or driver that propagated through every layer of the planet at once. This is the bifurcation point, a threshold in dynamical systems theory where the Earth has been pushed so far that the return to the old equilibrium is no longer guaranteed. This is why the simulation glitch hypothesis has become such a viral obsession in the corners of the internet where people feel the world is glitching. When a system's baseline stability vanishes, it looks like a software failure. We see Schumann resonance spikes or frequency jumps and interpret them as spiritual upgrades or system instabilities because our brains are hyper-tuned to recognize the pattern illusion. But the truth in the mirror is even more profound. The static we feel in our lives, the anxiety, the sense that time is accelerating, the feeling that the ground is no longer steady, is the biological expression of a planet that has shifted gears. We are not watching a disaster, we are watching a recalibration. Geological history tells us that transition periods, not the states at their end, are when systems are most sensitive. During these phases, small additional forces produce large, unpredictable responses, and thresholds are crossed without warning. We are currently riding that wave of sensitivity. The 1.59 millisecond acceleration of the Earth's spin or the 9% decline in our magnetic shield are merely the symptoms of a world that is searching for a new baseline. Human civilization was designed for the extraordinary calm, but the shared excitation of 2010 marks the end of that era. The mirror in the data reveals that our fear isn't really about the core or the ice, it's about the limits of our assumptions. We assumed the Earth was a static stage, but it is a dynamic, tightly coupled engine that has just entered a high variability regime. The signals coming from the deep Earth, the atmosphere and the poles are a quiet summary of a planet in motion, a world that refuses to be a perfect clock for us any longer. As the data continues to come in, sharpening the picture of this new equilibrium, we are forced to realize that the most important science of the next century won't be about stopping the change. It will be about reading it accurately enough to know what comes next. We live on a world that is enormously old and endlessly active, operating on time scales that dwarf human memory. The rotation anomaly, the wandering axis, and the weakening shield are not messages of doom, but prompts to rebuild our infrastructure and our expectations for a non-stationary future. The instruments are running, the satellites are watching, and every millisecond of a shorter day carries information from the deep interior to the surface. The planet is not sending us a signal. It is simply breathing in a way we haven't seen before. The mystery of what changed in the early 2010s is still being solved, but the mirror is already clear. The world has changed. The transition is underway, and the extraordinary calm has officially left the building. We have travelled from the white-hot iron heart at the centre of our world to the fraying edges of our magnetic shield, tracing a pattern that defies the statistical baselines of human history. We have seen how the inner core's rotation paused in 2009 and reversed, potentially as part of a 70-year oscillation that is now unloading its angular momentum upward to the surface. We have explored the structural decay of our magnetic armour, specifically the South Atlantic anomaly, which is not only expanding by an area half the size of Europe, but is actively splitting into two separate holes in our shield. We have looked at the record-breaking acceleration of the planet's spin, which produced the shortest days in the history of atomic timekeeping on June 29th, 2022, and July 5th, 2024, forcing us toward the hole in time known as the negative leap second. And we have mapped the wandering of the geographic North Pole, which abandoned its century-long trek toward Canada to race 17 centimeters per year toward Greenland as the planet physically rebalances itself in response to melting ice and groundwater depletion. The no BS reality is that these are not isolated geological accidents. The data from 2010 to 2020 shows an unprecedented alignment where 7 independent planetary systems, from the deep core to the atmosphere, all departed from their historical baselines in the same decadal window. The probability of this happening by coincidence is nearly zero. It suggests a shared excitation, a system-wide transition where the extraordinary calm that built human civilization is being replaced by a non-stationary state. While viral theories of simulation glitches or spiritual frequency jumps attempt to explain this through emotional filters, the physical truth is more profound. The design specifications of our global infrastructure, our power grids, navigation satellites, and financial markets were built for a planet that no longer behaves according to the old models. As we approach the 2035 deadline to eliminate the leap second, we are acknowledging that the Earth is no longer a reliable enough clock to govern the world we've built. We are now in the transition phase, the most sensitive window in any planetary cycle, where small forces produce large responses and thresholds are crossed without warning. The strange things happening to Earth right now are not messages of doom, but prompts to adapt to a world that is shifting gears. The mystery we see in the data is ultimately a mirror, reflecting the limits of our assumptions and the need for a new equilibrium. The planet is not broken, but it is changing, and for the first time, we have the instruments to watch the transition in real time. The story of our world is no longer about stability. It is about the courage to follow the data wherever it leads next.